Now that you understand how the ECG readout in an individual lead is generated, we need to make sure that you are familiar with the nomenclature of this readout. Remember, the deflection produced by atrial depolarization is termed a P wave, while ventricular depolarization produces the QRS complex. The nomenclature of the QRS complex can cause some confusion, but is in fact quite straightforward. Within the QRS complex, any positive deflection, that is, a deflection above the isoelectric line, is termed an R wave. Any negative deflection which follows an R wave is termed an S wave. However, if the first deflection of the QRS complex is negative, this deflection is termed a Q wave. This is important. A Q wave can only exist if and only if the first deflection of the QRS complex is negative. A negative deflection following a positive deflection, no matter how small that positive deflection may be, is an S wave. In lead V1, the classical morphology of the QRS complex is a small R wave followed by a larger S wave, while in lead V6, an initial small negative deflection, a Q wave, is followed by a large R wave. In the example shown here, there is no S wave present in lead V6, although a small S wave is seen in this lead in many normal ECGs. The section of the ECG recording connecting the end of the QRS complex and the beginning of the T wave is termed the ST segment, and the junction between the ST segment and the end of the QRS complex is termed the J point. As all of the ventricular muscle mass is depolarized at this time, there is no flow of current through the heart, and the J point and the ST segment should therefore lie on the isoelectric line. This is generally true, but you will learn later in this course that there are normal ECG variants in which the ST segment lies above the isoelectric line. This becomes very important when we go on to try and identify patients with myocardial infarctions, but that's for later. Finally, the diffuse deflection produced by ventricular repolarization is termed a T wave, and as we've seen in video 2, the T wave tends to be concordant with the preceding QRS complex. We will now go on in video 4 of this section to teach you the position of the leads of a standard 12-lead ECG relative to the heart. Knowledge of these positions will allow you to understand the morphology of the ECG readout and will pay dividends in clinical practice.